Okay, hello. So we're back now. This is a more advanced question, really. Here they're asking for us to make up half equations and then a full equation for a redox reaction. Okay, a redox reaction is one where something gets reduced and something else gets oxidized. So it says acidified aqueous solution. If it's acidified, there are H plus ions around. That's good because we use H plus if we ever need to soak up oxygen from a compound to make water. It's a very valuable tool for us. So often we'll see acidified written. That means that we can use H plus in our equations. Nitrate ions, which are NO3 minus, react with copper metal, so that's just Cu itself, forming nitrogen monoxide and copper 2 ions. Okay, so there's one reaction here where copper is going from copper to copper 2 plus, a 1/2 equation, and the other half equation is going to be nitrate going to nitrogen monoxide and some other things. Okay, so we split it into two, sort out what the electron change is, and then put them into one. So first they're asking us half equation for the oxidation of copper to copper 2 plus. Okay. So start on the left hand side. We have copper. And we always think about the oxidation state as we go because we're going to need to know how many electrons to use. Copper, what's the oxidation state of any element on its own, must be 0. So copper's in oxidation state of 0. And we know it's going to go to, we leave space just in case we need to put electrons, it's going to go to copper 2 plus. The oxidation state of something, if it's just an ion in 2 plus, it must be the same as its charge because there's nothing else, there's no other atoms contributing towards that, so they're going to be copper in plus 2 oxidation state. Let's put it here. Roman numerals because it's an oxidation state. So if this thing is going up in oxidation state from 0 to 2, it must be getting oxidized because the oxidation state is a value of how oxidized it is. So if it's going up in oxidation state, it must be getting oxidized. We know from oil rig that oxidation state is losing electrons. So if it's going up in 2 oxidation states, it must have lost 2 electrons. If it's lost them, they're no longer part of the copper, they're extra, and they're on the right-hand side. A way to check, once you've looked at the oxidation states, a way to check everything's happy is look at whether the charge is balanced on your equation. Overall, if there's a copper atom, there's no charge. On the right-hand side, 2 plus 2e minus, well, the 2 plus and the 2e minus and the 2 times 1 negative charge cancel out, so we know that's balanced. So that one's good, so that's done. Okay. So let's go on to the next one. Let's go on to the reduction in acidified solution. Again, they're telling you acidified solution. They're hammering into you to use H plus in this equation. Of nitrate ions into nitrogen monoxide. Okay. So nitrate we know is the NO3 minus ion, and we know it's going to go to nitrogen monoxide, just NO. Okay. First thing we have to do is look for the oxidation states. We always look for the oxidation states first and spot what's getting oxidized and what's getting reduced. Okay. So which is the most electronegative out of nitrogen and oxygen? It's oxygen. Oxygen wants to be a 2 minus ion because it's group 6, it wants 2 extra electrons. So oxygen's oxidation state is -2. So we need to think what must nitrogen's oxidation state be to cancel out all these oxygen atoms and make the overall charge only -1 instead of what the oxygen would want it to be, which is -6. It doesn't want it to be, but that's what it would be if there's nothing cancelling it, cancelling any of these out. Because 3 times -2 is -6. So there's 3 atoms times -2 equals -6. So the nitrogen, in overall to get this -6 up to only -1, the nitrogen must be +5. Okay, there's one of them. 1 times +5 equals 5. 5 minus 6 is -1, so that all works, all the maths works there. So the nitrogen must be +5, plus V, because we're talking Roman numerals if you're writing it in there, okay? Now let's have a look at what the nitrogen is and the oxygen is in this one. Well, the oxygen still is the most electronegative thing. It dominates, it's not getting reduced or oxidized here, it's still -2. Okay? It still wants those 2 electrons more than nitrogen wants its electrons. It dominates and becomes the -2. So if there's 1 oxygen and 1 nitrogen, the nitrogen must therefore be +2, because there's no charge in the overall thing, so it must be +2. So what is the atom here that has had a redox reaction? Which is the atom that's changed its oxidation state? Oxygen hasn't, so it must be the nitrogen. Nitrogen has gone from 5 to 2. So its oxidation state has lowered, it's gone from 5 to 2. So it must be getting reduced, it must be getting less oxidized, so it must be getting reduced. So if it's gone from 5 to 2, it's gotten reduced by 3, so it needs, reduction is a gain, oil rig, RIG, reduction is gain of electrons. If it's getting reduced, it needs 3 extra electrons to go from the +5 to +2. Okay? So these 3 extra electrons, if they're getting gained, they must be on the left-hand side. They're getting gained in there, and then they're in there, in the nitrogen atom, so we're not going to have them outside there in the equation again. So that's a reduction equation. Now we've done the important stuff, now we just tidy it up. Okay, we need to balance it because it's a normal equation. Half equation is just the same for you have to balance it in charge, you have to balance it in atoms. Okay? Now we know there's 3 oxygens on the left-hand side and 1 nitrogen. On the right-hand side there's still 1 nitrogen, but only 1 oxygen. So in a way we have to get rid of 2 oxygens. Now how we do that is we soak them up with H+. So you can add H+, it's in acidified solution, that's fine. Add H+, and it's going to react to form water. If we have 2 extra oxygens, 3 minus 1 is 2, we must make 2 molecules of water because there's 1 oxygen every water. So that needs 1, 2 times 2, 4 hydrogen ions. So we must have 4 hydrogen ions. Okay. And that's actually us finished, but we check by seeing if our equation is balanced in terms of charge. We know where the atoms are, we counted up the atoms and it works. Let's try the charge. Overall 1 minus there, 3 minus there, so 4 minus, plus 4H plus is cancelled out, 0. On the right hand side, that's got no charge, 0. So we're pretty confident we got that right. Okay? Now the last step to put our 2 half equations together is to make sure that when we add them together, we literally just squash them up and add them to each other. We need to make sure that these electrons fully cancel out, because a full equation can never have electrons on the right or the left hand side. Okay, because all these electrons that are being reduced by the copper need to get sucked in and used by the nitrogen. If we only have 2 given in, but 3 are needed, it doesn't work out. Okay, so what we have to do is we cross multiply to make sure the equations balance, and when we add them together, everything works. Okay, so okay, good. So once we've got our 2 half equations, we know the balance, we know that we've checked they're okay with the charge, and we've checked that they're good. Then we just need to put them together. Now, if we're going to put them together, we need to make sure that we've got the same amount of electrons on the left-hand side and the right-hand side, because the electrons come from the copper and they go to the nitrogen, so they're not coming in from outside of the system, they're just inside there already. So you have to make the copper produce enough electrons to give it exactly to the nitrogen. So in order to get the same amount of electrons on each side, the easiest thing to do is always to cross-multiply. Okay, so we times the whole of this equation by how many electrons here it needs. So we're going to times the whole of this equation by 3, because there's 3 electrons here needed. And if we times the whole of this equation by how many electrons there are needed, so we times this whole one by 2, because there's 2 electrons there. Now that is going to be 2 times 3 is 6 electrons, lovely. 3 times 2 is 6 electrons. Okay, so we always get it balanced, because 3 times 2 is always the same as 2 times 3. 7 times 9 is always the same as 9 times 7. So you always cross multiply. Okay, so last step, I'm going to do it in 1, and if I'm careful, it's going to work. 3, and I'm going to write everything on the left-hand side of either of my arrows on the left-hand side of my arrow. Everything on the right-hand side of either of my arrows on the right-hand side, then I'm going to do some cancelling if needs be. So, 3 coppers, 3 Cu plus nothing else on the left-hand side of this one, so just down here, 3 E minus, but we're timesing it by 2. So 6 E minus plus 2 times NO3. 2 NO3 minus 2 times 4 is 8. So plus 8 H plus. Nothing else there. Good. That's my reactants done. Products. 3 Cu2 plus. 6, 3 times 2. E minus 2 NO 4 2 times 2 H2O. Last thing to do is cancel out anything that's on the same left and right hand side of the equation. Sometimes you'll have like a few H pluses on this side and more H pluses on that side, so we'd make sure we only have H pluses on one side and the rest of them cancel out. This one we don't have that problem, not that it's a problem, we just have electrons to cancel out. If we've done it right, this would be exactly the same, and they are 6 electrons, 6 electrons. You can just draw it straight like that, you don't need to write out again. If you just draw it crossed out like that, it's fine. They can, in a way that it's nice that you get to see you're working there. 3Cu is not the same on the right hand side, because Cu is not the same as Cu2+. Cu2+ has lost 2 electrons, different species there. NO3, no NO3s on the right hand side, only NO. No H pluses on the right hand side, so we don't go any cancelling. None of these on the left hand side, none of these on the left hand side, and none of these on the left hand side. So we're done. Okay, and you always check at the end. One way to check that I'm along the right lines is my charge balance. 3 times 2 plus is 6 plus, nothing else is charged on the right hand side. Right hand side 6 plus, left hand side we have 2 times 1 minus is 2 minus, and 8 times 1 plus is 8 plus, 8 minus 2 is 6 plus, so we cancel that out. So 6 plus, everything's looking balanced, all the atoms are balanced, so we're happy that's done. Okay. Could we have done this straight away without looking at half equations? Well, you would have been there all day with trial and error. Look how complicated this is. You need 3 Cus, 2 of them, 8 H pluses. You need to break it into 2 half equations to make a full equation. If you try and go here, sometimes they won't break it down for you. They'll say, write an equation for a reaction, and maybe only give you 2 marks or 3 marks. Now, you need to write the 2 half equations, which are easy, to be honest. When we just write the half equations, they're easy. You put them together to make a whole equation. Try and do this right at the start, and you're going to go in trouble. Okay? So remember, 2 half equations, 1 full equation.